Hello students, welcome to MemoNeet. This is Ravikant, your physics teacher, and welcome to the part 2 of laws of motion, which is the syllabus of your BTS 7. In our last video, we saw the first law and the second law of Newton's laws of motion. What was first law? First law states that a body remains in a state of rest or motion unless and until an external force is applied on it. Right? From there we also understood about inertia and types of inertia, and then we went to the Newton's second law of motion, where we found that Newton's second law of motion states that the rate of change of linear momentum is directly proportional to the external force applied on the body, and the change in the momentum takes place in the direction of force, right? And from there we got the formula F is equal to mass into acceleration. We also saw some numericals. Now today we are going to study about Newton's third law. Now, the previous video I told you all that whatever has been explained over here will be well understood if you practice the questions and if you go for the questions in the PYQ book. Why PYQ book? Because in the PYQ book the questions are so arranged and so explained that it will help you understand the concept and the strategy for studying for a NEET examination. Right? So if you practice your questions from PYQ book, it will be very easy for you to understand the concept and understand the result, right? So let's start with Newton's third law of motion. What Newton's third law of motion says? Newton's third law of motion says that a body when applies an action, a body when applies some action on another body, the another body will return a reaction, right? That means the simple statement which Newton's third law of motion says that every action has equal and opposite reaction. Now, just to elaborate it, that let me tell you that whenever the force exists, for force to exist, there has to be two bodies. First body which is applying a force, and second body which is experiencing the force, right? So if we take that first body is applying the force, the second body will be experiencing the force. But at the same time, the second body is also applying the same amount of force on the first body, and the first body is experiencing it. For example, let's say that this is a table. Now this is a table, and on this table there is an object. This object will be having its mass, and because of acceleration due to gravity, it will be exerting its weight on the table. Let it be m into g, right? And this table will be exerting an equal and opposite force on this book, which we call as normal reaction force, denoted by gamma. Now, how I can say this that there is a normal reaction force acting on the book? I can say this because when the book is being kept on the table, the book is not moving by itself, right? The book is not moving by itself. It means that net force F net acting on the book is equals to 0. That is, the net force acting on the book is equals to 0. And we also know that if there is a book, definitely there is a force acting on the book which is equal to the weight of the body, that is equal to mg, and is directed towards the center of the earth. This force is definitely acting on the body, right? Now, if this force is acting on the body should move in the direction of force, right? But the body is not moving. It means there is some another force acting on the body which is in the opposite direction and is equal in the magnitude of the first force, because of which the net force on the body is coming equal to 0, and therefore the body is not moving from it. Hence, I can definitely say, I can surely say, I can confidently say that it's not only mg which is acting on the body, it's also a normal reaction force acting on it, right? So this m into g is being exerted on the body on by earth, right? Weight is the force exerted by earth on the body, right? But at the same time, because the earth is pulling the object towards itself, therefore this object will apply its weight on the table, and this weight will be acting as a reaction, acting as an action on the table, and as a reaction, a normal reaction force will be experienced by the object kept on the table, right? So what we find there here that mg is taken as action, then the normal reaction force is the reaction, right? Then the normal reaction force is the right. Now this mg is acting on table by object, right? Whereas this normal reaction force is acting on object by table, right? This is what is happening. So from here, what we conclude is that action reaction pair of forces are, first point, they are equal. Action reaction forces are equal and opposite. That is mg is equals to minus of n for the signal. Second point is they act on different bodies, right? They act on different bodies. As we can see from here that the weight of the body is being acted upon by the object on the table, whereas the normal reaction force is acted by the table on the object, right? Let's take some more examples to understand it. See, when suppose this is the surface on the floor and a person is standing on the floor, right? And the person wants to jump. Now to jump, what the person does is the person pushes the floor, pushes the floor, this being an action, and as a reaction, the floor pushes the body up, right? Pushes the body up, and as a result, the body jumps up, right? Jumps up. So when you are pushing the floor downwards, because of the reaction, you are jumping up, right? So here again, the action reaction forces are acting in equal and opposite direction, and they are acting on the two different bodies. So this is action reaction force, right? So what Newton's third law of motion says that Newton's third law of motion says that every action has equal and opposite reaction, and these action reaction pair of forces always act on different bodies. It is not like that the same body will be experiencing both action and reaction, right? This is not action reaction pair, right? So action reaction pair always act on two different bodies. That is, if I draw according to the example, this is the table which is experiencing weight and the body is experiencing normal reaction force, right? So this is what is action reaction force. So again I repeat, Newton's third law of motion says that every action has equal and opposite reaction, and this action reaction pair acts on two different bodies. If action is experienced by body 1, then the reaction will be experienced by the body 2, right? Now the next thing which we are going to study today here is, which is again an important topic related to your examination, that is law of conservation of linear momentum. Law of conservation of linear. What is this law of conservation of linear momentum? Law of conservation of linear momentum says that if F external, right, that is the external force. If external force acting on the body is equals to 0, then the momentum of the body remains conserved, right? Or in a better way, instead of using the word body, I would use the word system, right? Now suppose there is a system which contains different particles. Let's say we take an example of three particles having mass m1, m2, and m3, right? And they are having the respective velocities as v1, v2, and let's say v3 in three different directions, right? So initially, the momentum of the system will be the sum of the momentum of each particle, that is m1 v1 plus m2 v2 plus m3 v3, right? Now, if there is no force acting on the body, after some time, if you again observe whatever is the whatever the momentum was there initially, same will be the momentum after some time. That is, the final momentum will be equal to the initial momentum of the body of the system. That is the sum of the momentum of every particle will be equal at t is equal to 0 and at t is equal to t. That is, the momentum is not changing. You can well understand it from this mathematical expression which we saw yesterday. That is, F external is equal to dp by dt. Now, if F external is equal to 0, then this implies that T is constant, right? And if T is constant, this implies that P final is equal to P initial. That is, the final momentum is equal to initial momentum, as it is not changing, it is constant. So what law of conservation of linear momentum says that if no external force is acting on a body, then the momentum of the body remains conserved. That is, whatever it was initially, the same momentum will be fine. Right? This is the law of conservation of linear momentum. For better understanding of this concept, I would like to introduce few numericals which would help you to understand this law of conservation of linear momentum better. Right? Let's see the first question. The first question says that a 30 kg shell is flying at 48 meters per second. When it explodes, its one part of 18 kg stops, while the remaining part flies on. Find the velocity of the lead. Now, what we see here is what they are saying, that there is a shell. There is a shell of mass 30 kg, right? And it is at rest. Oh no, it's flying at a speed of it is flying at a speed of 48 meter per second. So from here, what we can say that initially its momentum is equal to its mass into its velocity. This is its initial moment, right? Now what happened? It explodes. It explodes into two fragments. One of one of its fragment is of 18 kg, and another of it would be definitely of 12 kgs, because 18 plus 12 is equals to 30, right? So one is of 18 kgs, another is of 12 kgs. Now this the one part which is of 18 kg, it stops. It means its velocity is equal to 0. And this 12 kg is flying, right? Let's assume it's flying, and we do not know the velocity of this 18 kg, sorry, 12 kg particle. So we need to calculate. Let's take it as v, right? Let's take it as v. So since there is no external force has been applied, there is no external force has been applied on this 30 kg shell. It was the internal chemical reaction or internal some forces acting on the body, because of which what happened? The body exploded. Now, because the there was something which was happening internally, there was no external force involved. That is, F external F external was equal to 0, therefore the momentum is conserved. That is, we can say P final is equal to P initial, right? So initially there is only one particle in the system that is of mass 30 kg. Now there are two particles in the system that is of one of 18 kg and another is of 12 kg, right? So final momentum P final will be written as 18, that is the mass of the first particle, into 0, that is the velocity of the first particle, plus second particle's mass, that is 12 kg, into its velocity, which we do not know, right? So, because no external force is acting on the body, the momentum remains conserved. There is no external force acting. Why? Why we can say so? It's nowhere written in the question, as well as the body is not being accelerated. And as I told you in the last lecture, that if the acceleration of the body is zero, or the change in the velocity of the body is zero, there will be no acceleration, and if no acceleration, there will be no external force acting on the body, right? So here the no external force is acting on the body. Therefore, by law of conservation of linear momentum, we can say that Pf is equal to Pi, that is P final is equal to P initial. So putting the value here, P final, this would be equal to, this becomes 0. What we are left with is 12B. So we have P final as 12B is equal to P initial is equal to 30 into 48, right? So this would give us 12, and this is 4. So V will be equal to 120 meter per second, right? 120 meter per second. So what we find here is that by applying law of conservation of linear momentum, we got the velocity of the second particle. That the second particle will be flying with a velocity of 120 meter per second. Now we would had find the direction of the velocity, because velocity is a vector quantity. But the thing is, neither the velocity initial velocity direction of the initial velocity is being given to us, nor the uh, they have asked us. So because initial direction of the velocity is not being given, so we cannot find here, but the magnitude can be calculated. So the final momentum of the body, velocity of the 12 kilogram particle is 120 meter per second, right? I hope the explanation for this question is clear. So now let's move to the next numerical. So the next numerical says that a body of mass 1 kg initially at rest explodes and breaks into three fragments, right, of masses in the ratio 1 is to 1 is to 3. The two pieces of equal mass fly off perpendicular to each other with a speed of 30 meter per second each. What is the velocity of the heavier fragment, right? So what is happening over here is we are having a body which is of 1 kg. Now it is breaking into, let's say, three parts which are in the ratio 1 is to 1 is to 3, right? Which are in the ratio 1 is to 1 is to 3. It means 1x plus 1x plus 3x is equal to how much? 1 kilogram. So 5x is equal to 1 kilogram. So your x is equal to 1 by 5 kilograms. The bodies are having a mass. This will be having a mass of 1 by 5. This will also having a mass of 1 by 5. And this will be having a mass of 3 by 5 kg. Right? Now, what they are saying that the mass 1 kg initially at rest. If it is initially at rest, we can say that P initial is equal to m into 0, that is equal to 0. What we find that P initial is equal to 0. Now they are saying that the masses of the two pieces of equal mass fly off perpendicular to each other with a speed of 30 meter per second each. So these two particles fly off perpendicular to each other. Let's say this one of the particle is flying in this direction, then the other of the particle will be flying in this direction, right? And with the speed of 30 meters per second and 30 meters per second, right? So if we find the magnitude here, the magnitude of the momentum P of let's say P1 will be the uh, momentum of the particles of mass 1. So P1 will be equals to mass, that is 1 by 5 into velocity is 30, right? Velocity is 30. So we can say it's 6 Newton second. So what is the scenario over here is, here it is 6 Newton second, and in this direction it is 6 Newton second, right? Now the angle between them is 90 degrees. Now there are two equal vectors separated by an angle theta. Now theta is equals to how much? Theta is equals to 90 degree. And for this equivalent force will be equal to, let's say, velocity momentum will be equal to, let's say, P 2. Let's say P2 will be equal to 2 into 6 into cos 45. Now, which formula I have used? I have used the formula that resultant force will be equal to 2a cos theta by 2, where a is the magnitude of the equal vector and theta is the angle between the two equal vectors. So, whenever two equal vectors of same magnitude and vectors of same magnitude are separated by angle theta, the resultant is given by the formula r is equal to 2a cos theta by 2, right? So, putting that, what we get here is equals to this is equals to how much? And this will give you 6 root 2. This will give you 6 root 2. So 6 root 2 is the resultant velocity of these two vectors, and that would be in this direction, let's say, right? 6 root 2. So now what is the scenario if I explain it with the help of a diagram? That this was a particle out of which one of the particles is gaining momentum in this direction, another particle is gaining momentum in this direction, and the resultant of these two particles is equal to in this direction. If I remove this and this, the third particle, to keep the momentum conserved, need to have the velocity in the direction opposite to the this resultant momentum P2, right? So the particle with a heavier mass, that is a 3m, the 3m should move in the direction opposite of the direction of the velocity, resultant velocity of the two equal masses, right? So why so? Because as we can see that there is no external force acting on the body, that is F external is equal to 0. So the momentum will remain conserved, and we saw that the momentum of the body initially is equal to 0, right? So finally also it should be 0. So P final should also be equal to 0. Now to keep P final equal to 0, the momentum gained by these two particles should be equal and opposite to the momentum gained by the heavier particle, right? So using the mathematical expressions, that F external is equals to 0, then this implies that P initial is equals to P final. We have P initial as 0. What is P final? P final is your 1 by 5 into 30 into 1 by root 2, this whole into, this is the momentum of one particle, and into 2, right? Plus 3 by 5 into, we do not know the velocity, right? So from here we'll get 0 is equals to 6 root 2 plus 3 by 5 b, right? So from here we can say that V is equals to minus 6 root 2 upon 3 by 5, and this would be equals to minus 6 root 2 upon 3 into 5. So this will give you 10 into root 2, which is equal to 14.14 meter per second. And this is your answer, right? So this is the velocity which the heavier particle will. If I just recollect what I have done is, this was a part, this was a shell exploded. If two of them are gaining velocity in this direction, then the resultant velocity, or you can say resultant momentum, would be somewhere in this direction. Then the third particle has to gain momentum in this direction in order to keep linear momentum conserved. Why we want the linear momentum to be conserved? Because there is no external force acting. It was the internal forces or internal chemical reaction, or internally something happened because of this shell exploded, and the shell, when exploded, it broke into three particles, out of which two were of equal mass, and third particle was three times the mass of the first two particles, right? That is, if first two were m and m, then third particle was of p. Now initially the momentum of the particle was zero, so we write it as pi is equal to zero. Why it is zero? Because the particle is at rest. Now p final will be equals to m into its velocity plus m into its velocity, and that too in the vector form, plus 3m into its velocity. Let me write it here. Plus 3m into its velocity, let it be v1, right? So when we do the vector sum of these three momentum, we will get p final, and then we equate this p final equals to zero. We'll get the value of this v1. So what's the trick, or what is the punch over here is that you have to find the vector sum. You have to find the vector sum of all the velocities. So what I have done is, here, when I calculated 6 root 2, when I calculated the 6 root 2, this was the vector sum, magnitude of the vector sum of the two velocities of this m and m. Now this momentum has to be equal and opposite to the momentum gained by the heavier fragment. When calculating this, we get final velocity of the heavier fragment is equal to 14.14 meters per second. Right? Now let's come to the third question. The third question says that a gun weighing 4 kg fires a bullet of 80 grams with a velocity of 120 meter per second. With what velocity the gun recoils? Right? Now, see what is happening. You are having a gun in your hand. When you are having a gun in your hand, the momentum of the gun and the bullet all together, or the system of a bullet, that is, sorry, a gun having a bullet inside it. This whole thing is at rest. Because the whole thing is at rest, we will say that P initial is equals to zero. Now the bullet is being fired. So what is happening? That the bullet of mass equals to 80 gram is gaining a velocity of 120 meter per second, and let's take it as m1 and v1, and the gun of mass m2 is equals to 4 kg, will be gaining some velocity, let's say v2. Now since the initial momentum is equals to zero, the final momentum also has to be zero. Why? Because there is no external force acting on a gun. When a gun is being fired, it is some internal mechanism because of which the bullet gets fired out of the gun. So because there is some internal mechanism, there is no external force acting, right? There is no external force acting because there is no external force acting. So by law of conservation of linear momentum, P final has to be equal to P initial. Now what will be P final? From here we can say that P final is equal to 80 into 12. So 80, it's in gram now. So 80 into 10 to the power of minus 3 will make it into kilograms. Then 80 into 10 to the power of minus 3 into 12 plus 4 kilograms into V2, and we need to calculate V2. So by law of conservation of linear momentum, P final, that is 80 into 10 to the power of minus 3 into 12 is equals to 4 times of V2. So this is 41420. So it will give you 24 to 40 into 10 to the power of, right, 240 10 to the power of minus 3, which is equals to V2. Now this will be equals to, from here we get V2 is equals to 0.24 meter per second, or you can say that V2 is equals to 2.4 centimeter per second. So the gun will recoil with a velocity of 24 centimeter per second, right? How I came to this line? What is P final? P final is 80 into 10 to the power of minus 3 into, well, mass into velocity, plus P initial is, sorry, plus 4 into V2, and P initial is 0, right? So it will become 80 into 10 to the power of minus 3 into 12 is equals to minus 4 into V2. So from here we can say that minus V2 is equals to 0.24 meter per second. That is V2 is equals to minus 2.4 centimeter per second. So the gun recoils because, if suppose this is the gun, suppose this is the gun and this is the bullet. The bullet is taking velocity in this direction, so definitely the gun has to take velocity in this direction so that the momentum of the two bodies of the system, or two particles of the system, have momentum in opposite direction, and they cancel out each other to get the net momentum equals to 0. Why net momentum is equals to 0? So that the law of conservation of momentum prevails, that is P initial is equals to P final, because there is no external force acting on the system. There is no external force acting on the system. Why I am saying so? Because the bullet is being fired because of some internal mechanism occurring inside the gun. It's nowhere externally happening. So the net force acting on the gun externally is equals to 0, and because this is so, the net force external is equals to 0, so the momentum will remain conserved, and momentum remain conserved means initial momentum is equals to final momentum. What is the initial momentum of the gun? The initial momentum of the gun is equals to 0. So the final momentum of the gun has to be 0. For the final momentum to be 0, if the bullet is gaining velocity in one direction, the gun has to gain velocity in the just opposite direction, right? And this is what the calculation is to be done. This is how we calculate the velocity, or this is how we apply the law of conservation of linear momentum in the numericals, right? So in this lecture today, what we have studied is the Newton's third law of motion and law of conservation of freedom. So what Newton's third law of motion says? Newton's third law of motion says that every action has equal and opposite reaction, right? Every action has equal and opposite reaction. these action reaction force always takes place on two different bodies, right? Action reaction takes place on the two different bodies. That is, action reaction forces are equal and opposite, and they act on two different bodies. If action is acting on body A, the reaction has to be acted on body B. This cannot happen that both action and reaction are acting on the same, right? This was Newton's third law of motion. Now coming to the next topic, that is law of conservation of linear momentum. What law of conservation of linear momentum says? The law of conservation of linear momentum says that if external force acting on a body or on a system is equal to zero, then the momentum remains conserved for that system or the body. Momentum remains conserved means final momentum will always be equal to the initial momentum. Whatever the momentum was initially for the system, that will be the same for the time duration, or it will be same as, or it will be called as final momentum, and that final momentum will be same, right? So P final is equals to P initial. Whatever was the momentum of the system initially, that would be same final, right? This is what is law of conservation of linear momentum. I hope I tried to make the things very clear with a simple example. I hope the things are clear to you all. Go through the video very well, and just as I told you, if you want to understand the concept very well, the very thing after seeing the lecture you are supposed to do is solve the numericals of related topics. The numericals related to the topic you can get in the PYQ book or in the MemoNeet or the MemoNeet app. Also, you can get the numericals for this. Solve them, have a good practice, right? And then be ready for the quiz in the evening, right? That is all from my side. Thank you.